Today, our topic is comparison between JFET and FET. Comparison of JFET and FET, JFET and BJT. So JFET means junction field effect transistor and BJT means bipolar junction transistor. Today we will see. So before going to that, we will discuss what is discussed in previous session. So in previous session, we talked about introduction to FET. So in introduction to FET, we detailedly learn about FET. So FET is a voltage control device, whereas BJT is a current control device. FET is a voltage control device. Why we are calling voltage control device, or FET is a variable resistor is also. So FET is a voltage control device because the output current is controlled by the input voltage. So by varying the input voltage, we can control the output current. That's why we call it as FET is a voltage control device. So output current is controlled by varying the input voltage. So that's why we call it as FET is a voltage control device. And also we've seen FET is a unipolar device. So in a previous BJT, bipolar junction transistor, that is bipolar. Bipolar means two polar, either majority or minority. Here FET is a unipolar device because the current conduction is only by the majority charge carriers. Current conduction is only by the majority charge carriers. That's why we call it as FET is a unipolar device, BJT is a bipolar device. So the terminals, we will come to, we know that BJT also 3-terminal and FET is also a 3-terminal. So these 3 terminals of a FET are named as, one is drain, second one is source, third one is gate. So these are the 3 terminals. Out of these terminals, gate terminal act as a controlling element here. So FET has a 3 terminals, gate, source and drain. Out of these 3 terminals, gate is act as a controlling element. We can control the output current. So by varying the input voltage, we can control the output current. That's why FET we call it as a voltage controlled device. Okay. FET is a more temperature stable as compared to BJT. So FET is more temperature stable as compared to BJT. Okay. So why we call it as field effect transistor? So the field effect transistor is abbreviated as a FET, F-E-T, FET, is the another semiconductor device like BJT. Okay, so this FET can be used as a amplifier or switch also. Okay, like BJT, FET is also a 3-terminal device. However, the principle of operation of FET is completely different from the BJT. So both are 3-terminal, both are transistors, but operation is different. Okay. The name of field effect is derived from the fact that the flow of current through the conducting region is controlled by the electric field. Here FET, the flow of current is controlled by the electric field. Because of that reason, FET is a field effect. So one field through current conduction is through only field, not junction here. In BJT junction, current conduction through junctions. Here, current conduction through field. That's why this transistor we call it as a field effect transistor. Okay, so these are the things we discussed in previous sessions. So types of, before going to that, we have three terminals. What are they? Source, drain, and a gate. So what do you mean by source? So this terminal, that means source terminal, connected to the negative terminal of the battery. So source terminal is connected to the negative terminal of the battery. So electrons, which are the majority charge carriers in the n-type bar, enter the bar through this terminal. So you always remember, source terminal can always connected to negative terminal. Like we know that. So this is a FET. If conventional current direction is, it is a n channel FET. So n channel FET. So we know that this terminal is the gate terminal. This terminal is the drain terminal. This terminal is the source terminal. So this is the FET symbol. So source means here voltage, one battery voltage is connected. So this is the plus terminal, this is the minus terminal. So this negative terminal is always connected to the source terminal. This positive terminal is always connected to the gate terminal. Here voltage is VGS, means gate source voltage. Here input voltage is this, in voltage we call it as input voltage. So this voltage is VGS. So that means source terminal is always connected to the negative terminal. So this is the plus, this is the minus. So negative terminal is always connected to the source terminal. Okay. And what about drain terminal? So drain terminal is connected to the positive terminal of the battery. Drain terminal is connected to the positive terminal of the battery. So this is the positive terminal, this is the negative terminal. So this is negative, this is positive. So here one ground. So this voltage we call it as VDS, means drain source voltage. So we have to remember, source terminal is always connected to the negative bar, and the drain terminal is always connected to the positive bar. So that is the basic thing. So what about gate terminal? Here two terminals connections. Okay. What about gate terminal? So gate is a heavily doped p-type silicon device. Silicon is diffused on both sides of the n-type silicon bar, by which these layers are joined together and called as a gate. Okay. So gate is a heavily doped p-type. So here N, S is the N bar, D is the N material, then G is the P material. Okay, so that is called field effect transistors. So types of field effect transistors are classification into different types. One is JFET. JFET means this one. One is JFET, junction FET. So junction FET and MOSFET, two types, junction FET and MOSFET. So junction FET again divided into N channel JFET and P channel JFET. Okay, just we are interchanging the material. If channel is N channel means drain and source are N and gate is P. If P channel JFET means N D and drain and source P material and gate is N material. That is the difference. Then MOSFET. So MOSFET means metal oxide semiconductor FET. So metal oxide semiconductor FET. SC semiconductor FET. And also we call it as IG-FET, insulated gate field effect transistor. IG-FET is nothing but insulated gate metal oxide insulated gate field effect transistor. And also we call it as MOST. MOST means metal oxide silicon transistor. Metal oxide we also called as MOST. MOST means metal oxide silicon transistor. Metal oxide silicon transistor. So these are the different names of MOSFET. IG-FET or MOST. IG-FET means insulated gate field effect transistor. MOST means metal oxide silicon transistor. Okay, so this MOSFET can be divided into two types. One is enhancement MOSFET and a depletion MOSFET. So in enhancement MOSFET, current is more, current conduction is more compared to depletion MOSFET. So again, enhancement MOSFET can be classified into N-channel MOSFET, N-channel enhanced MOSFET, P-channel enhanced MOSFET. Only materials are interchanged, then we will call it as N-channel and P-channel. Here also depletion MOSFET, N-channel D MOSFET and P-channel D MOSFET. But the symbols are different. So this is a enhancement type means this is one symbol, this is one symbol, this is one symbol, this is one symbol. 4 symbols of FETs. In GATE, graduate up to test in engineering, national test, these symbols also asked which one is the N-channel enhancement MOSFET among 4. Likewise, they are asking in GATE examination also. So these symbols are very different, very important also. These very different among 4. So these are the classification of field effect transistor. So we seen up to P-channel JFET. Today we will discuss about comparison between BJT and JFET. Next class we will see about what about enhancement MOSFET and depletion MOSFET. Okay. So this is the comparison of JFET and BJT. So first column is the parameter. Second column is the BJT, bipolar junction transistor. Third column is JFET. JFET means junction FET. So parameter is carrier. Parameter is carrier. So what about BJT here? Bipolar. So majority and minority carriers. Here carriers are both majority carriers and minority carriers. Here only unipolar means majority charge carriers only. So this is the symbol. This is the symbol means transistor BJT symbol. So this is a BJT symbol. This is the FET symbol. Okay, this is the N channel. This is common emitter. I mean N channel. Here also N channel. So conventional current direction is outward this symbol means it is a N channel. Here also it is a N channel. Next, device type. So current control device. BJT is a current control device. FET is a voltage control device. Why voltage control device? So output current is controlled by varying the input voltage. That's why it is a voltage control device. Input impedance is very low. Here FET is having very high. Because of input impedance, FET has many advantages. We will see later. So gain, high gain in BJT and a low to medium gain in FET. So power, so it consumes more power, BJT, whereas FET it consumes less power. This is the main advantages, power. Next, noise level. Noise level is high because reverse saturation current is increases in BJT, so noise levels are very high. Whereas JFET or FET, we will get only low noise. So thermal stability. So thermal stability is low and here thermal stability is high. Why thermal stability is low here means when temperature is increases, BJT parameters are changes. One is base to emitter voltage, uh, amplification factor beta, VBE and IC. If temperature is changes, increases means this parameter is changes. Due to these changes, collector current is increases more. If there is no compensation circuit means transistor may burn out. That's why in transistors comes compensation techniques as well as stabilization techniques because it is a instability. So stability is very low in BJT. So that's why we redesign the circuit like compensation by using a diode compensation, thermistor compensation, and sensistor compensation. We see in second previous session BJT's lecture. That's why it is a instability that is low. Thermal stability is low. Here thermal stability is high. What about size? So BJT is a large in size, whereas FET is a small in size. This is the main advantage. Very small means we can use VLSI technology, very large scale integration. So every computer motherboard, these FETs are integrated. It is a small size means more number of, so occupation of the space means very less here. So many number of trans FET are integrated into your chip. Here size is more means not we are not accommodate more number of transistor in motherboard. Here small means we can accommodate more number of FETs because it is a very small, that means less space. So integration, we can integrate thousands of transistors in a motherboard. That is the main advantages in JFET. Next, application preferences. It is preferred in low current applications. BJT, we will prefer low current applications. So FET, we will prefer low voltage applications. Okay, so these are the main differences. Okay, main differences between JFET and BJT. Okay, so here we can observe FET, field effect transistor operation only depends on flow of majority charge carriers. Just now we seen only one direction, majority charge carriers. So FET called as unipolar device. It is only depends on majority. That's why we call it as unipolar device. So BJT operation depends on both, here both majority and minority. That's why we call it as bipolar. That's why we call it as bipolar device, BJT, bipolar device. BJT means bipolar device. FET has no junctions, only channels. And the conduction is through N-type or P-type semiconductors. So FET has a less noise than BJT. So in the input circuit of FET is a reverse bias. So FET exhibits higher input impedance. FET exhibits higher input impedance and a lower output impedance. So FET act as a buffer amplifier. So buffer amplifier is nothing but whatever the input is given to the buffer amplifier, same output will get into the output side. That is called buffer amplifier. In communication, we will use this one, buffer amplifier. But BJT has low output impedance because its input circuit is forward bias. Input circuit is forward bias. In fact, input circuit is reverse bias. So FET is a voltage control device, whereas BJT is a current control device. Why FET is a voltage control device? Output current of the FET is controlled by varying the input voltage VGS. That's why we call it as FET is a voltage control device. Then FETs are much easier to fabricate, particularly suitable for ICs. IC means integrated circuits, or integrated circuit means VLSI, very large scale integrations. Different things, small scale integrations, large scale integrations, LIS, small scale integration, SSIC, VLSI, and now present technology is GLSI, gained, sorry, uh, gained scale integration, GSIC. So FETs are much easier to fabricate and particularly suitable for ICs because it occupies very less space. So size is very small. So that's why we used in IC technology. FETs are more temperature stable than BJT. FETs are more temperature stable than BJT. So BJTs are cheaper than to produce than FET. BJT are cheaper. Because of cheaper, we are always using BJT. Based on our applications, we prefer FETs. So both BJT is used as an amplifier and switch. FET is also used as an amplifier and switch. But based on our requirement, we prefer to use FET or BJT because BJT is a cheaper, FET is a costly. So these are the differences between FET, JFET, and BJT. Now we will see the applications of FET or JFET. So first one is FET is used as a buffer in measuring instruments and receivers since it has high input impedance and a low output impedance. Because of this advantage, FET can be used as a buffer in measuring instruments. Why FET is a high input impedance? We are connecting the input terminal to negative bias, so reverse bias. That's why FET impedance is a very high at input side, input impedance, and output side a low output impedance. So FET are used as RF amplifier. FET are used as RF amplifier. That means radio frequency amplifiers in FM tuners and communication equipment for the low noise level. So for this purpose, we also use BJT. If BJT is using for RF amplifiers in FM tuners, then what is the disadvantage? So noise levels are more in BJT. If noise levels are more means communication may be uh, disturbances. So noise levels is low in FET means, so here FET we will prefer in communications because noise levels are very less. Since the input capacitance is low, FETs are used in cascade amplifier. cascade amplifier. So what do you mean by cascade amplifier? Means we are connecting one by one, because it is having output side is low output impedance. We are adding to other section, second stage, next third stage, fourth stage, like that we are adding the FET amplifier. Stage 1 like RC coupled amplifier, first stage, second stage, third stage. We are adding different stages. Multi-stage amplifiers means gain will increase. Here also cascade amplifiers means we are adding section by section for improvement of gain. Amplifiers in measuring and test equipment. So the device is a voltage controlled. It is used as a voltage variable resistor in operational amplifier. It's the main advantage. So FET is a voltage controlled. It is used as a variable voltage variable resistor. So in the place of resistor also we use this FET, field effect transistor. So this voltage variable resistor in operational amplifiers. Okay. Operational amplifier symbol is like this. We'll come to know. This is a positive inverting non-inverting terminal. So this is the input voltage V1 and V2, two input voltages we will get output. So one IC is there, IC 741. So this is called operational amplifier. We will see in a coming semester. This is also an amplifier, operational amplifier. We are giving two inputs, we will get only one output. So here in operational amplifier fabrication, this is IC. IC 741 is the name of operational amplifier. In operational amplifier IC, FET is used as a voltage variable resistor. FET is used as a voltage variable resistor. So FETs are used as a mixer circuits in FM and TV receivers in communication purpose. So FETs are used in oscillator circuits. See, many advantages having FET, because it is having high input impedance and a low noise and a less space. Okay, FETs are used in a digital circuits in computers like motherboards, memory circuits, because of its small size. So in memory circuits, we know that RTL. RTL means resistor, transistor logic, TTL. So these are the different gates, transistor logic, DTL, diode transistor logic. So we will see this unit only. We will see all these logic families, how we will operate. So transistor, resistor, transistor logic, what is the output? Transistor logic, what is the output? What is the input? We will see. Diode transistor logic, like that HTL, high threshold transistor logic. So these logic families we are using BJT as well as FET based on our requirement. Coming classes we will see the logics. After 2 classes I will start digital logic families. Okay, after completion of the FET I will start the digital. Our subject is analog and digital. So analog is 95% over. Now coming session I will start digital electronics. Okay, so FETs are used in a digital circuits, computers, motherboards, memory circuits, because of its small size. So these are the applications of junction field effect transistors. Okay. Okay. Today's class I will summarize what we discussed in this session. So in this session we talked about types of FETs. So FETs are 2 types. One is junction FET, other one is MOSFET or IGFET or MOS. So junction FET is divided into 2 types, N channel JFET and P channel JFET. Similarly, MOSFET can be classified into enhancement MOSFET and depletion MOSFET. Again, enhancement MOSFET can be classified into N-channel enhancement MOSFET and P-channel enhancement MOSFET. Similarly, depletion MOSFET can be classified into N-channel depletion MOSFET and P-channel depletion MOSFET. And we will see in the comparison of JFET and BJT, comparison table and applications of JFET. Okay. Okay, thank you.